Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello, Senior 3 Chemistry class. You're most welcome for today's lesson. We are continuing with the Unit 1, that is carbon and its inorganic compounds. Carbon and its inorganic compounds. All right? We are heading to chemical properties of carbon. You remember in the previous lesson we were talking about carbon, forms of carbon, we were talking about the physical properties of carbon, but for today we are heading to chemical properties of carbon. And remember, when we talk about chemical properties, we are emphasizing with the reactions, all right? Reaction of carbon with other elements or other substances. Good? So, hope everybody is ready to start with the lesson. Isn't it? All right. So, what is the objective of today's lesson? The objective of today's lesson is, at the end of this lesson, everybody here in this class will be able to explain the chemical properties of carbon and its compounds. All right? You will be able to explain the chemical properties of carbon. How does carbon react with other substances or compounds or elements? Those are, when we talk of chemical properties, those are reactions. All right? Good. Different from physical properties. Physical properties, they make up the physical appearance of an element or of a compound or anything. But when we go to chemical properties, we expect to find there some reactions, all right? So at the end of this lesson, as the objective of today's lesson, you will be able to explain the chemical properties of carbon and its compounds. Good. Hope you are very ready for that. Now, let's start off. Let us start off. Look on the slide. On the slide, you're seeing charcoal burning, all right? Charcoal burning there. A burning charcoal in oxygen. That is the reaction of carbon with oxygen. As I said, when we are talking about chemical properties, we are talking about reactions. So we are talking about reaction with oxygen. So burning charcoal in oxygen. So what takes place? That's what we need to see. So when we talk of charcoal, we are talking about carbon, all right? When charcoal will continue to burn in a gas jar even after heating is stopped. So when you're heating charcoal, all right, in a gas jar where there is oxygen, all right, this is a gas jar, there is enough oxygen, then you heat charcoal, then you stop the heating, you will find that this charcoal will continue to burn, all right? It will continue to burn even when the heating has stopped. So how will you detect that charcoal continues to burn when the heating has stopped? In fact, normally, when charcoal, that is carbon, reacts, when carbon reacts, that is the equation here. When carbon is in a solid state, all right? When carbon, that is charcoal, as I said, burns in oxygen, we expect or we have to get carbon dioxide gas and some heat or some energy, all right? So how will we detect or how will we know that this is carbon dioxide that is formed? Or how will we know that in this gas jar, where we have been burning this charcoal and we have stopped burning, that this charcoal is continuing to burn? So we shall find that there is a gas that is going liberated, and when we test for that gas, the gas that is given off, we shall use what we call calcium hydroxide. All right? Calcium hydroxide, normally this is the testing reagent. This is what we use to test for the presence of carbon dioxide. What happens? Normally, calcium hydroxide is colorless, all right? Call it lime water. Calcium hydroxide, another name is lime water. So when you happen to get this calcium hydroxide solution, it is colorless normally, it's colorless. So when you let carbon dioxide to bubble into this calcium hydroxide, you find that the colorless gas turns into milky, right? Something which is white, kind of milky. It was colorless, now it is milky. Therefore, the calcium hydroxide solution turned milky due to the carbon dioxide gas formed when charcoal burnt in the gas jar for oxygen. You get that? We have said that you have a gas jar. I repeat this. As I said, for the chemical properties, we look at the reactions. So we start by looking at the reaction of carbon with oxygen, all right? So this is a gas jar. In a gas jar, we have there oxygen, all right? So we burn there charcoal or carbon, all right? So when we burn it, it will even continue to burn in absence of heat because of this presence of oxygen, all right? Now, how will we verify that it is continuing to burn? We shall test that, or in other words, what do we expect when carbon reacts with oxygen? We expect to get carbon dioxide gas and some energy. How will we test for that? How will we confirm that? The gas that is liberated when we hit carbon or when we burn carbon in oxygen, we use it's lime water. Call it lime water or calcium hydroxide. As I said, lime water or calcium hydroxide normally is colorless. It has no colors. You see water. So when you let carbon dioxide come into contact with lime water, which is colorless, the color of this that is colorless, it has to turn into milky. So when it turns into milky, you confirm that the gas liberated is carbon dioxide. All right? So that is the confirmatory test for carbon dioxide. You happen to be asked that question in one exam. They ask you, what is the confirmatory test for carbon dioxide? You have to say it's calcium hydroxide or lime water, whereby the lime water with contact with carbon dioxide, it forms a milky, kind of milky. Why? But you can ask why. What happens? Look at this. Look on the slide. Look at this equation here. All right? Normally, calcium hydroxide, as I said, is colorless. When it happens to combine with oxygen, come into contact with carbon dioxide, it forms what we call calcium carbonate and water. All right? So calcium carbonate is milky. The color of calcium carbonate is milky, whitish kind. So that's why we say the confirmatory test for carbon dioxide is to turn lime water or calcium hydroxide from colorless to milky state or to whitish. All right? The white precipitate that is formed, that is calcium carbonate. All right? Calcium carbonate. Calcium carbonate, when you look at it, it is white precipitate. All right? Milky, in other words. So, when you continue to burn or to introduce in a lot of carbon dioxide, that is like saying you have now calcium carbonate and water, this product here. You continue to bubble in carbon dioxide, the whole thing will form what we call calcium hydrogen carbonate. Now, this calcium hydrogen carbonate is also colorless. So the milky color or the white precipitate will disappear and goes back to colorless. All right? You need to know these steps. I have carbon dioxide. I make it to be bubbled into lime water or calcium hydroxide. I form what we call calcium carbonate. Calcium carbonate is white precipitate or milky kind. So when I continue to introduce in a lot of carbon dioxide, to bubble in a lot of carbon dioxide, this calcium carbonate and water will combine. As it combines with a lot of carbon dioxide, it forms calcium hydrogen carbonate. And calcium hydrogen carbonate is colorless. So you find that the white precipitate disappears to form a colorless solution. All right? Good. Those are the reactions. So when you react carbon dioxide with calcium hydroxide, you form calcium carbonate with water. Then calcium carbonate with water, you continue to put in carbon dioxide, you form calcium hydrogen carbonate, which is colorless also. I think it is clear. So carbon reacts, we are still looking at the reaction of carbon with the oxygen. Now, carbon reacts with oxygen in a limited state. In a limited state, we are saying supply of oxygen in a limited state. We form carbon monoxide and heat some energy. All right? You react carbon with oxygen, you form carbon monoxide with some energy or some heat here. But when you react, in case there is no excess of, like this one here, the first equation, look on top here. When you react carbon in excess of oxygen, enough oxygen, these two equations, the first and the last, it is you can misunderstand them by saying, oh no, teacher, you're saying carbon with oxygen, you get carbon dioxide and heat. But for the last one, you have said we form carbon monoxide. What is the difference? The difference is the first one where we say carbon plus oxygen to form carbon dioxide is when oxygen is full. Enough oxygen, excess of oxygen. When we react carbon with excess of oxygen, we form carbon dioxide plus heat. But when we react the last one now, look at the last one. When we react carbon in the limited amount of oxygen, you can even put a half here, you get carbon monoxide and some heat. I hope we have understood the difference. In case you come across the two equations, don't misunderstand them. The one where there is enough oxygen and the one where there is little oxygen, there is a big difference. The one with a little or limited oxygen, you form carbon monoxide and heat. The one with excess oxygen, you form carbon dioxide and heat. All right? Good. So we have finished looking at the reaction of carbon and oxygen. Now, reaction with carbon dioxide. What happens when I get this carbon dioxide I've got, then I react it with carbon. So when the carbon dioxide is passed through heated charcoal, the charcoal diminishes. A gas is produced that turns or that burns with a blue flame. What does this mean? It means I'm having the other charcoal burning, continuing to burn in oxygen. Then I pass there this charcoal, right? It will diminish or it will stop. That's why normally we say that carbon dioxide stops burning, right? It stops burning. So we form what we call carbon monoxide. Carbon monoxide has a blue flame. It has a blue flame. That is it. Now, reaction with iron 3 oxide. So remember, we are still looking at the chemical properties of carbon, or that is carbon or charcoal. And when we talk of carbon, we're emphasizing, when we talk of chemical properties, we are emphasizing with reactions with different elements or compounds. Now, we are heading on reaction with iron 3 oxide, right? Reaction of carbon with iron 3 oxide. It's here. When you look into that, this is charcoal. When I talk of charcoal, remember that is carbon, because we looked into charcoal as a form of carbon in the introduction of the lesson. So whenever a point of charcoal, get to know I'm talking about carbon, all right? Because you may ask yourself, teacher, you're talking of charcoal, and on the other hand, you're talking of carbon, so you're trying to confuse us. No, I'm not confusing you, because in the introduction, we saw that charcoal is a form of carbon. So charcoal can be represented by carbon, in other words, all right? So we have carbon here. We have iron 3 oxides, all right? Then we have the heating here, heating source. So what happens? That's what we are going to say. The reaction of carbon or charcoal with iron 3 oxide. Good. So what happens when you react the two? So when you react iron 3 oxide and powdered charcoal, a red glow is produced. The glow continues spreading throughout the mixture even when heating is stopped. The color of the mixture turns from red-brown before heating to gray after heating. So carbon in the charcoal reacts with iron 3 oxide to form iron metal and carbon dioxide. This is a Redox reaction where carbon reduces iron from its oxide and is itself oxidized to carbon dioxide. The reaction is exothermic and hence continues even after heating. What does this mean? So go on the equation here. On the equation here, we have iron 3 oxide. This is iron 3 oxide, all right? When you react it with carbon, all right? The oxygen, you see, we have said it is a redox reaction. What does a redox reaction mean? It means that this carbon has added itself to oxygen, all right? It has reduced iron from its oxide, and the iron is alone here. Then it has oxidized itself to form carbon dioxide. Addition of oxygen. What is oxidation? Oxidation, removal of oxygen. That is the addition of oxygen on a substance. Addition of oxygen on a substance or an element. Then the reduction, that is removal of oxygen. Removal of oxygen, addition of oxygen. That's what we have there, the redox reaction. So iron has been reduced. Oxygen from iron here has been reduced, and the left iron alone, and oxidized it on carbon here. So there we form this red-brown color of iron 3 oxide turns into it becomes gray. Because with carbon dioxide, we don't look at it because it's just a gas that is being liberated or given off. All right? So in brief, when iron 3 oxide reacts with carbon, we form iron plus carbon dioxide. The color turns from red-brown to gray-brown. Red-brown of iron 3 oxide to iron, which is gray in color, and some carbon dioxide that is going to be, or that is liberated or given off. All right? Good. So we are still looking at the reactions, chemical properties of carbon. How does carbon react with different compounds, with different elements? That's the work we are in, the lesson we're having today. So now, how does carbon, the next now is the reaction of carbon with concentrated sulfuric acid and nitric acid. All right? Reaction of carbon with concentrated sulfuric acid and nitric acid. Remember in senior 1 here, we talked of sulfuric acid and nitric acid as strong acids, all right? So we are seeing how does these strong acids react or behave when they come into contact with carbon, all right? So we are saying that carbon reacts with concentrated sulfuric acid to form carbon dioxide, sulfur dioxide, and water, all right? When you react carbon with sulfuric acid, come on the equation here. This is carbon plus sulfuric acid. You get carbon dioxide, sulfur dioxide, and water. But when you react carbon with nitric acid, you get what we call carbon dioxide, nitrogen dioxide, plus water. All right? So this acid oxidizes to carbon to form carbon dioxide. It is the carbon dioxide gas that turns lime water milky. I talked about that. So these acids oxidize carbon to carbon dioxide, form carbon dioxide. I think you have seen here. We had carbon dioxide. Remember the term oxidation, addition of oxygen. Carbon had no oxygen, But at the end, we always talk of the reactants and products. I think this is clear in Senior 1. Senior 1, you learned about the reactants, and after NALO, we talk of the product. So before here, we have carbon solid, but in the products, we have carbon dioxide. So it means that carbon has added on oxygen. There is oxygen that has been added on carbon to form carbon dioxide. So it has been oxidized. These acids has oxidized carbon to form carbon dioxide. All right? The same applies to nitric acid. It was carbon in the reactants, but jump into the products after the arrow. You have to know after an arrow, we call these ones products, what is formed. So you see it was carbon, now it is carbon dioxide. It means carbon has gained oxygen. So that process of gaining oxygen, we call it oxidation. All right? Good. So I think when we talk about these reactions, the chemical properties of carbon, we shall even continue to look at them in the next lesson. But per now, I think you have understood how carbon reacts with oxygen when it is limited oxygen and when it is excess oxygen. When it is limited oxygen, we have said we form carbon monoxide. All right? Limited oxygen below here, we form carbon monoxide. But when it is excess oxygen, we form carbon dioxide. All right? And you have seen how to test the confirmatory test of carbon dioxide. The confirmatory test of carbon dioxide, that is what? Who can remind us? The confirmatory test of carbon dioxide? Yeah, that is calcium hydroxide, whereby calcium hydroxide, when reacts or when bubbled into carbon dioxide, we form calcium carbonate and water. And calcium hydroxide before, it is colorless. But when we come to calcium carbonate, it is milky or white precipitate. But you remember, that's why, in fact, when we are studying the rules doing a practical, that your eyes should be always on the practical, all right? You're doing, don't look side and side. Because like for this case, you happen to be heating as you're trying to collect this gas into calcium hydroxide. So you will first see the colorless gas disappearing to form a white precipitate. But as you continue, if you were somebody who was murmuring around, all right, it can disappear, and you come back when it is colorless, and you ask yourself, oh, nothing has changed, all right? But remember, the calcium hydroxide is colorless, but calcium carbonate is a white precipitate, all right? So when you continue to bubble in carbon dioxide, calcium carbonate, the white precipitate will disappear due to the formation of calcium hydrogen carbonate. Here, calcium hydrogen carbonate, because calcium carbonate plus carbon dioxide, this is this product here, you get calcium hydrogen carbonate, which is colorless. So the former colorless of calcium hydroxide comes back, so you can get confused between the two, all right? Good. So I've also looked at how carbon dioxide reacts with carbon or charcoal. We have said that carbon dioxide stops burning, or in other words, when we have carbon dioxide, that carbon dioxide is passed through heated charcoal, the charcoal diminishes, or it starts to stop burning, forming a blue flame. That is carbon monoxide that is being formed. So carbon dioxide has that capacity of stopping combustion. Normally when you see these fire extinguishers around, you will see carbon dioxide written on the label. It is carbon dioxide that is there, which is used to stop burning in case there is fire outbreak. That carbon dioxide When it's spread around, when there is fire outbreak, you find that fire is put down. All right? That is the role of carbon dioxide. Instead of carbon dioxide plus carbon, you get carbon monoxide, which is a blue flame. So as we have been talking about the reactions with iron 3 or so, we said iron 3 oxide. Iron 3 oxide is red-brown. When it reacts with carbon, it forms a gray color. That gray color forms from the formation of iron. All right? Good. So when we talk about, we have also talked about reaction with concentrated sulfuric acid, reaction with concentrated nitric acid. I think also that one has been very interesting, and you have picked it. All right? Good. So let me leave you with a small work that you're going to do when you go back home. This is a small exercise that you have to do when you reach home. Number one, carbon reacts with carbon dioxide according to the equation below, this one. Carbon dioxide plus, we talked about that. So identify the substance that loses oxygen and the one that gains oxygen from the reaction above. All right? So carbon reacts with oxygen according to this equation. What condition is required in 1 and what equation is required in 2 to form these ones here. Carbon plus oxygen to get carbon dioxide, carbon plus oxygen to get carbon monoxide. What has happened in each? I talked about that. What does the heat in the equation indicate about the two reactions, right? We talked of the word exothermic, production of heat. Endothermic, there's no production of heat, all right? So, write balanced chemical equation for the reaction that takes place when you react carbon with concentrated nitric acid, when you react carbon with concentrated nitric acid. We have talked about that in the last reaction, all right? So I think the lesson has been very interesting, and I have enjoyed it because I've seen your good attention. Thank you so much for today's lesson. Let's meet in the next lesson. Thank you. Bye.